Question 12. So there are two graphs. One of it is displacement against time. The second one is displacement against distance. So we have to deduce the angular frequency. Oh, okay. We have to deduce the angular frequency and wave number. Okay, so if you are confused on how to determine what's the value here, what's the value here, since this is actually at like a three quarter of the graph. Okay, so what I would do is from the displacement against times graph, we obtain the amplitude lah. Similar for this graph as well, but first we are gonna write down the amplitude. Next, since we will obtain two information from one graph, which is from the x-axis lagi lah. So from the x-axis, for this graph, we could get the period. Tapi sekarang ni, the period is here, okay? So how do we find the value here if we only have the value 6 here? So what I would do is, this is one wavelength. This is another half of the wavelength. So if we add this together, we can actually get 1.5 lambda. 1.5 lambda, which is equal to 6 seconds. Okay? Boleh faham ke tu? Boleh faham kali kan kamu? Alright, so 1 lambda. Sorry, 1 lambda lah pula. That is sorry. So period. No. So this is one complete cycle, and this is half complete, half oscillation. So this is half. So add these two together, you will get 1.5 t equal to 6 seconds. So berapa nilai t? T is equal to 6 divided by 1.5, which is equal to 4 seconds. So that is the period. Next, untuk this graph, we have obtained the amplitude. Now we have to look at the x component, which is distance. So untuk distance, this is lambda. This is half lambda. So this is 1.5 lambda equal to 7.5. So lambda is equal to 7.5 divided by 1.5, which gives you the wavelength to be equal to 5 cm. Okay, macam tu je yang apa kamu perlu buat kalau dia bagi halfway. Kalau dia bagi di sini pun, this is half of the, sama jugalah, begitu jugalah. So this is one complete cycle, this is half. This is one complete cycle plus half. Gitulah, kamu perlu ingat yang macam tu. Alright, so from that we can then determine the angular frequency, which is equal to 2 pi over t. So t is the one that we've calculated, which is 4. So the angular frequency is equal to 0.5 pi radian per second. Next, we have to do for the wave number. So wave number is equal to 2 pi over lambda. So 2 pi over lambda, which is 5 centimeter. So you can either use centimeter ataupun meter lah. Tapi this is gonna be 0.4 pi per centimeter. If you convert it into meter, you will get 40 pi per meter. Okay? Alright, so that is on question A. Why do I don't hear any song? Oh, ada ba sikit. Nanti terlampau kuat pula. Never mind, everybody. Just listen to my voice. Okay, so question B, the wave propagation velocity is gonna be v equal to f lambda. So f is 1 over t lambda. So that is lambda over t. Lambda is, balik-balik yung mabat ni. Di pala. Lambda is equal to 5 ataupun 0.05 over the period which is 4 seconds, is it? Yeah. So kamu akan dapat 1.25 times 10 negative 2 meter per second. Is it? Let me just double check. Ish, senang lagi kini. It's just 0.0125 meter per second. Okay? Alright, question C pula. The particle vibrational velocity when displaced vertically 1.2 cm from the equilibrium position. So, sekarang ni dia bagi kita nilai Y, which is 1.2 cm. So, that is 0.0012. Salah. Yeah, okay. So, at y is equal to 0.012 meter, we have to determine the particle vibrational velocity lah. So, this equation is the equation that we've used before, which is this one. So, omega is 0.5 pi, a is 2 centimeter, so a is 0.02 meter. Okay, so 0.02 minus 0.012 square. So you'll get the particle vibrational velocity to be equal to 2.51 0.0251 meter per second is yeah, let me just double check for you. 0.5 pi 0.02 square minus 12 square, yeah, 0.0251 meter per second. Oh, actually, don't forget to add this here. I think I have that in the notes if I'm not mistaken. Yeah, so tulis je lah yang ni plus minus ni untuk this graph lah, yang displacement against distance ni. The one yang before, the subtopic before, don't really need that. Okay, so lepas tu dia minta kita write down the displacement equation supposing the wave is moving to the left. So kalau dia moving to the left, dia akan jadi positive. So that's gonna be y is sine omega t plus kx. So we have everything. A is 0.02 sine 0.5 pi t minus plus, sorry, it's plus not minus. K is 40 pi x. Okay, so don't forget to declare the punya unit where x and y are in meter, t is in second. Okay, all right, so that is the solution for question number 12.